Hello, Doug. You're muted, Doug.
May, did you toss me out?
No,
Did you start this meeting?
I went in to start it and it was already started.
Okay, I don't know what happened. I thought I was the host and I thought I started it, and now I don't think I'm the host.
Oh,
Yes, I am still the host. Okay. Wow,
okay.
I don't know what happened. I got thrown out when someone else came in and started it. It threw me out.
Well, yeah, I came in and I got thrown out too. So I don't know
Okay.
why it was throwing people out, but maybe we've got it worked out since we got 3 of us now. Maybe it's letting people in okay.
I'm the co-host. You're the host. I don't know how that happened.
I got thrown out too, but I'm back.
So
Well, all
May,
3 of us got thrown out. Okay.
It
okay,
said someone
so-
else started the meeting.
all right, so May, it's listing you as host and showing me as co-host.
Okay, I'm not really sure if I know how to change that.
Oh, you don't need to change it, I guess. Just when Dave Evans gets in, we need to make him a co-host or set him up so he can share his screen.
Well,
You know how to do that?
it may, well, when I set up the meetings for small meetings like this, like 20 or 25 people, I set it up so that everybody can share
Oh,
when I
okay.
set it up. So I don't know how Terry set it up though.
I think Connor set these meetings up.
Oh, okay. Well, I thought Connor called Terry to get Terry to help
Okay.
with some stuff, and I don't know what Terry did.
Okay.
But hopefully it'll just let everybody share. Let's see what it says. I can't really tell from this.
One participant can share time.
Well, if one person can share at a time, we're okay.
All right. What the heck happened just now? What is this?
So yeah, my screen changed too.
What's going on here?
Well, I've got 2 things that came on at the top. One says you're screen sharing and the other one says stop share.
You're sharing your screen right now?
Well, it says,
Okay, I see it.
I don't know why it says both of those things up there,
Okay, whatever.
as long as it works.
Okay. And you're doing,
What did you say? I think you froze, Doug.
not me. Is just, can you unshare your screen?
I don't know. I don't intend to be sharing my screen at all.
Well, you are.
So I don't know what it's doing. I can go out and come back in if that would help.
Says you're in it.
So team viewer has come in. I'm going to go out and come back in.
Okay. Just I, I'm still seeing your entire screen.
I don't know why.
There we go. Now she's out.
How you doing, Doug?
I'm doing okay.
I just got in. Oh,
Well, I'm not sure what I did, but I finally got that picture to show up. It's been sitting there for a couple of months, and it's the first time it's actually showed up.
we've missed out for a couple months then. That's a great picture.
I love that picture. Actually, you know that that glass thing you used to see on TV, that fractured glass? I took and put it on that, so it's on glass, and it really looks nice.
Cool. I like the color. It's a lot more red than I've often seen it.
Well, I like the red and the blue, so I went ahead and kind of accented it a little bit. Just because you see the flaming nebula, they're usually a little whiter, and I says, nah, I like it.
Doug, you got the word. I'm only going to do Phoenix tonight.
No, I didn't know that, but that's okay with me.
Yeah, I was going to do Phoenix and Hydrus, but I found more interesting stuff on Phoenix than I expected.
Okay. Let's give people a few more minutes to get in. May went out and she's trying to get back in, but I think she's having problems. And I don't know if anybody else is joining us. We'll give them a few minutes. There's Kay. Hi, Kay. Waiting for May to get back in. She left us for a few minutes. See if she can get back in.
So my sister sent me a picture from her balcony in Indiana of the very
Eclipse?
partial solar eclipse.
Ah, okay.
It was just like a little bite out of the sun.
Well, my brother lives in the northern peninsula of Michigan, and he might have gotten like 90%.
Wow, yeah.
So I'm curious whether he got up early and took any pictures. He's retired, so I don't know if he bothered to get up.
It was pretty. But yeah, the people that got to see the whole thing though.
He would have had a really nice view looking right over Lake Superior.
Oh, man. Of course, you might have snow up there yet.
No, 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 no. In fact, they've had record heat in the northern peninsula for the last several days. They've actually had like 95 degrees in Marquette.
Well, we're gonna have 111 or something.
Tomorrow
So
or Saturday. Great.
yeah.
Just when I'm coming out there.
Well, it should be nice at Timpa.
When
It'll
it
probably
gets
be
dark,
90 degrees.
it won't be nice at 6
It'll be-
o'clock.
It won't be cold.
No, it won't be cold.
Yeah, and I'm heading down to CAC this weekend, and it's supposed to be partially cloudy down there.
Hmm.
So I'll end up just camping.
Yeah, we don't want any clouds. Oh yeah, because there's a chance of rain or something.
Not on Saturday.
Really?
I just checked the weather forecast. They're saying mostly clear Saturday night.
Oh, that's good. That's better than the last thing. Where do you look? Maybe I'm not looking at the right place.
National Weather Service Tucson office.
Oh, okay.
So I've got about 10 constellations to go.
Okay. I'm going to give May a couple more minutes and then we'll just get started without her. She must be having trouble getting back in. She had to get out because something went wrong. There was a message telling her internet was unreliable and she needed to check out of the meeting, and she said she'd try to check back in.
Well, you know, the only time I ever get that message that says that my internet is unreliable is when I'm on Zoom. And it comes on and then it goes away and then it never has any consequence. So it's like I would certainly not sign off because of that.
Well, her screen froze up. She started to do a
Oh.
screen share and everything froze up on her, and so she had to get out.
All right, hello, everybody.
Otherwise we would
Yeah,
still
go.
be looking at her screen.
Hey,
Hey,
Gus.
Gus.
You're out at Timpa?
No, he's not.
Yes, I am, sure.
No, no. That's his background picture.
Oh, that's your background slide.
It's my fantasy to live at Timpa.
Huh.
Well, maybe
I
not.
would have thought that your fantasy would be to live at CAC.
Oh, well, yeah, that's probably a little bit better. It's kind of far. Oh, Doug, I sent you a JPEG of that of the TAAA logo.
I
know,
got
that
one.
round-
Okay, I'll look at yours. I got one from Terry, and then I also went on the website, and as it turns out, in the member area, where all the documents are stored, there's a logo there. And it was the same one that Terry had sent me, so I think that's the right one.
Is it the one that says established 1954 along the bottom?
Yeah,
Yeah, okay.
I think that's our official logo.
That's the official one, yeah, because I remember asking our previous president, Ben,
Yeah.
is that the
And-
official? He said, that's the official one. I said, okay. And
And
the stickers that I had ordered have that established 1954, since that is the official logo, so.
And someone needs
Okay.
to change the website because our website has the other logo.
Yeah,
I think I need to turn on some light.
Okay, we're gonna go ahead and get started. May can, when she gets in, she gets in. Welcome, everybody. This is the June meeting of the Tucson Amateur Astronomy Association Astronomy Fundamentals Special Interest Group. We're going to have two presentations tonight. Mr. David Evans is going to do our constellation of the month, and he's going to do the constellation of Phoenix. And then that'll be followed by my presentation, and I'm going to basically finish up our tour of the planets. I'm going to do a presentation on Mercury. So with that being said, go ahead, David.
All right.
You should be
Get
able to
rolling.
do a screen share. Looks like we got it.
There, can everybody see my introductory slide?
Yes.
Yeah, you might want to go to full screen mode.
It's great started.
Hang on just a minute. How about
There you
that?
go. That's
there you go. All right.
very good.
Still playing around navigating with two monitors.
Ah, okay.
So tonight I thought I would do a better know constellation Phoenix. I was originally going to do Phoenix and Hydra in one presentation, but I found a lot of interesting stuff on Phoenix. So I'm just going to do Phoenix alone. It's another one of these constellations that I've never seen. Matter of fact, I only vaguely remembered it as a constellation when I saw the list of the ones that weren't done. So this one's kind of interesting. It's the 37th largest constellation of the 88. Covers 469 square degrees of the sky. It's visible from 32 north to 80 south, but for us, it's only partially visible. I certainly would not expect to see the whole thing.
Hey, Dave,
Yeah,
is this a southern constellation?
yes,
In
it
the
is.
Southern hemisphere?
Yep.
Then it would be visible all the way to -90.
Yeah, you know, I thought that myself, and that's the day I pulled off Wikipedia. So
Wikipedia is not always right.
yeah, I know you see on the internet, and
It's visible to -90 if it's in the southern hemisphere.
all right, thanks, Doug. Appreciate that. So
Oh, yeah.
yeah, look at that. It's down there. The neighboring constellations are Urdanus, Grus, Fornax, Hydrus, Sculptor, and Tucana. And it's very, very far southern. No Messier objects, as you would suspect. And there are two meteor showers associated with this constellation, one in December and one in July. It has 10 stars that have confirmed exoplanets, but no huge number of exoplanets have been found in this constellation. So again, the constellation Phoenix was cataloged by our friend Planicus, and he based his observations that were conducted by the Dutch navigators de Hoopman and Keizer. And even though this is a rather small constellation, or maybe halfway to the middle, it's the largest of the 12 constellations that Planicus and de Hoopman, or excuse me, Planicus described in his globe of 1598. And then in 1603, Johann Bayer incorporated Phoenix in his Eurometria Atlas. So Phoenix, Pavo, Tucana, and Grus are all known as the southern birds.
That I didn't know.
Yeah, and Phoenix may be the most recognizable of these, only based on its mythology. And maybe that's just a perspective I have. I knew far more about the story of Phoenix than I knew about the mythology. So the mythology, the mythical Phoenix is known across many lands, including Greek, Persian, Arabic, Egyptian, Roman, Turkish, and Chinese and Indian cultures. The constellation itself was never described in those ancient cultures. So it really doesn't have a mythology associated with it, but the mythology of Phoenix is very interesting. It's said to have represented an eagle with purple, red, and gold feathers and a scarlet and gold tail. And that's a description from, I believe, Metamorphosis. So Ovid wrote in his Metamorphosis that the bird lived for 500 years. When it reached the end of its lifespan, the phoenix would build itself a nest on top of a palm tree. Using incense and cinnamon bark. Then he would ignite the nest and die in the fire. A new bird would be born from its father's ashes, and according to legend, when the young phoenix was strong enough, it would take the nest and carry it to the temple of Hyperion. And Hyperion was one of the 12 Titan deities and the Lord of Light. In another version of the tale, the young phoenix would embalm the ashes of the dead one in an egg made of mirth and carry the egg to the Egyptian city of Heliopolis. And this means the sun city in Greek. On the right is a picture of what people might imagine of phoenix to look like. In this case, it's an Asian golden pheasant, and certainly one of the most colorful birds I've ever seen. And part of the reason I included that in this presentation.
Have you actually seen one of those birds in person?
No, I never have.
I have.
Really, that's incredible.
At a Chinese zoo.
I just, for me, it's hard to imagine a bird with that much coloration. So it's pretty neat. So notable stars. There are 4 named stars in the constellation, and we'll cover several of them. The first one is Anka, and it's Alpha Phoenicius, or Phoenicius, excuse me. And the name comes from the Arabic word for phoenix. It's a spectroscopic binary and it lies 85 light years from Earth. The magnitude combined of this star is 2.37. So it's very visible. And the stars orbit each other every 10.5 years. The primary star is an orange giant star. You can see where it's circled there at the tip of the wing. The other star, which is notable, is Beta. And Beta is a binary star with a visual magnitude also fairly bright, of 3.32. And this one's really interesting. It's composed of 2 yellow giants. Their individual magnitudes are 4.0 and 4.1. And they orbit each other 168 years in a orbit that's highly elliptical. And they're really not sure why it is so, we expect planets to be elliptical, and I would expect that stars would be too, but this is highly elliptical, and the professionals aren't really sure why it's so oval. And another interesting fact about this binary is that they're both of the same spectral class of yellow giants. So they must have evolved at the same time in relatively the same environmental conditions, in most likely a single gas cloud. And we'll talk more about those gas clouds as we get down to deep sky objects. NAQ HD 6434 is not a named star. It's a named star, but it's actually not part of the constellation. It's a yellow sub-giant that's located 135 light years from Earth. And this is one of the stars that has an exoplanet around it. But the interesting thing in my mind about this star is it's 10.2 billion years old. And I would love to see this just to say that I've seen a star that old. It's telescopic and its magnitude 7.72. Another named star is Warren. And this is an eclipsing binary star, and it's an algo type variable. Its visual magnitude varies from 3.99 to 4.4 in a period of only 1.66 days. So it's a very quick variable compared to some other ones that I've talked about. Now, it's not simply a 2-star binary. There are also 2 other very dim stars, which make this a 4-star system. And I wanted to find a orbital pattern for this, but I wasn't able to. I thought it'd be very interesting to see how 4 stars orbit each other. The next star, I think, is probably the most interesting one. It's HE 0107-5240. It's an extremely metal poor early population star located 36,000 light years from Earth. When I say metal poor, what I'm suggesting is in the astronomy world, unlike the chemistry world or the geology world, anything that's not hydrogen, helium, or in some cases lithium is considered a metal. And this star has almost no metal. It's virtually hydrogen and helium. And when you compare the star to the sun, it has only 1/200,000th of the amount of metal in our sun. And this indicates that it formed an environment with much fewer metals and that is significantly older than our present stars like the sun. Talking a little bit more about population 1, 2, and 3 stars. Population 1 stars are like our sun. They tend to be concentrated in the disk and the arms of spiral galaxies. Population 2 stars, such as one we're talking about currently, formed earlier in the galaxy's history and exist primarily in the nucleus of the galaxy or in globular clusters. The oldest stars are population 3 stars. And we've never seen one, and it's highly unlikely that they still exist because they are the first, even though they're population 3, they're essentially the first generation of stars that formed after the Big Bang. And they are composed almost exclusively of hydrogen and helium and offer a door to understand the chemistry or the of the Big Bang. And
So
again,
David, I'm
yeah,
sorry. Is there, so that star you were just looking at on the previous slide, it's a population 2 star.
right.
So like you say, you would expect to find that either in the galactic core or in a globular cluster. So why is this one out here, like in the middle of nowhere? Is it like, is there a theory for why it ended up where it is? Like it got ejected from a globular cluster or got ejected out of the core?
Well, I don't know that for sure.
So
And
you didn't find any theory about
I didn't
how
find
where it
any.
is.
Yeah, I didn't find any theory.
That's
And
fine.
yeah, it's unusual, and I guess I didn't give enough thought to it. this whole area around the constellation Phoenix consists of amazingly quick star growth. And we'll see that a little bit later. So as you point out, it is unusual that you'd find such an old star in an area that is, very gas rich.
Right, yeah, because you're not looking towards the galactic core and you're not looking at a globular cluster. So I'm curious how it got there.
Yep. You know what? Maybe that's a future presentation because that's a great question, and I really don't know the answer for it.
I just thought I thought maybe you had dug up a little information on
No.
theory of what astronomers think, how it might have gotten where it is.
No.
All right, go ahead.
Yep, no problem. Good question, though. So we talked about this already. Let me skip one ahead. So let's look at deep sky objects. This one's a gorgeous one, a Hubble photograph of the Roberts Quartet, 4 galaxies, 160 light years from Earth, discovered by John Herschel in the 1830s. You were inclined to look it up. It would be NGC 87, NGC 88, 89, and 92. But what's interesting is that these galaxies are separated from by about 75,000 light years. But especially when you look at the galaxy up in the upper left-hand corner, there's really evidence of interaction. And they believe that interactions with another galaxy in this cluster. Which one, they're not sure, but certainly something's happened to that long spiral arm that comes down from I believe it's NGC 87.
Something else I find interesting. NGC 87, 88, 89, and 92. That's at the very start of the catalog. It's right at the beginning, right at the front end of the NGC catalog.
Yeah.
And so this I didn't know, but I'm going to look this up for myself. John Herschel must have started his catalog in the Southern Hemisphere.
Yeah,
if he's looking at Phoenix this early in the catalog.
Yeah, he must have. I wasn't aware of that, but that certainly makes sense. Especially since they're all consecutive as well, except for.
Well, obviously, you would have seen them all. Would have seen them all at the same time.
Yeah. Yeah.
Oh, you know what? I know what the explanation is. The right ascension for Phoenix is like 0 hours and 1 hour, right?
Right.
That's what it is. The catalog, the NGC catalog is in right ascension.
Oh, okay.
They're ordered by right ascension. So that's why these are early in the catalog. Okay. So, all right.
Oh, great. Here's another interesting one. ESO 243-49 is that beautiful spiral galaxy. And HLX 1-290 is a black hole. Now, what's interesting about this is not only is this galaxy gorgeous, but look what the location for that black hole. And it's
not in the center.
Way off center. The astronomers believe that this spiral cannibalized a much smaller dwarf galaxy. And that's why that thing's so far off. It's a 20,000 solar mass black hole, so it's not inconsequential. But what I find interesting is that it cannibalized a dwarf, but you sure don't see it in that picture. It looks pretty classic as a classic spiral to me.
I would be willing to bet if you ever saw this galaxy face on, you would see.
Yeah, you probably would see it that.
You'd see something.
Yep.
And this would be one of those galaxies that would have 2 black holes, because there's probably a black hole in the galactic core.
I would bet it does.
Yeah.
So that's an interesting one. So when I talked about, when we talked a little bit about why such an old star would be in this location, this complicates the issue more. So the Phoenix cluster, it's located 5.7 billion light years from Earth. This galaxy cluster is highly prolific. It has the highest rate of star formation ever observed around the middle of a cluster. And on top of that vast reservoir of interstellar gas, it's also a very powerful producer of X-rays. So that begs the question, if you have so much X-rays pushing out, why is that gas still all there? And not quite sure on that one. And the research that I dug into didn't have a lot of explanation around that. It's certainly a beauty. This picture is a combination of Hubble, a very large array, and the observatory in Chile, which I forget its name right off the top of my head. ESO. So it's a multiple, and also Hubble. So it's all multimedia picture. At the center of this rascal is a supermassive black hole. And you can see this picture in the X-ray, optical, and UV takes away a lot of that external core that we saw before. And the picture on the right is just a focused in. There is a supermassive black hole in the center of this. They're not sure how big, but they wonder, again, why that black hole hasn't knocked away all that reservoir gas. The belief is, and this needs a lot more study, is that this black hole is very undersized for the large mass of the cluster. And that allows for such rapid star formation. The belief is that eventually this black hole will become more massive. And when it does become more massive, it will blow off a lot more of that gas. And one of the questions is, you have normally a black hole inhibits star formation, but yet in this case, it hasn't. And why is that? And the belief right now is it's subsized, but that's really open to further investigation. The next one is El Gordo, the Fat Man cluster. And this is located at least 7 billion light years from Earth. And they're not really sure on that. There's a lot of delta in the different estimates. But it has an estimated mass of 3 quadrillion suns. Now that's 3 million billion suns. And I just can't get my arms around how massive that has to be. It appears to be comprised of 2 separate galaxy subclusters, which are colliding at really a colossal speed of several million kilometers per hour. And I included El Gordo just because I just can't get my arms around these massive, massive numbers and try to put them in terms that that we can understand. But it's certainly very, very interesting. And you'll see a lot of different pictures of El Gordo in the literature. Most of the time you see it without the large halo, but I thought it was an interesting picture to show just how massive this really is. So my sources for tonight were Wikipedia. That East Asian pheasant photo was off the internet. Jim Kaler's stars, and he's a professor at Illinois. 9planets.org was interesting, but of all the sites that I found, They were generally different from everybody else. But they did have some interesting information. And of course, Chandra X-ray and the Hubble Space Telescope rounded it out. Any questions?
Oh, I just put a comment in the chat.
Yeah, I was going to say the same thing. It looked like a comet, which is an interesting picture for a supercluster of galaxies. Can you go back to that slide where you showed the map of the
Yeah, sure.
constellation? So looking at that, we should actually be able to see it, the entire constellation from Tucson. We can see things here at Tucson down to minus 58 degrees.
Really?
So, yeah, and I just checked my planisphere, so the best time to see it would be November at around 9 o'clock.
Okay. You can see my Minnesota roots coming through, northern Minnesota roots. So I'll have to take a look for this one.
Yeah, because we're at 32 degrees plus, so we can see the minus 58. The horizon would be at minus 58.
Okay.
So this whole thing gets above the horizon. So you need a clear southern horizon,
Oh, cool.
which sounds like CAC or TIMPA maybe, in mid-November.
Got stuff
Oh,
in
cool.
the
Well, I'll be out there then. I would definitely like to see it. Now, most of the things I pointed out in this presentation are, especially the deep sky objects, are big scopes, probably not amateur scopes, but certainly worth trying to look at.
Yeah. Okay.
Well, thanks, everybody.
So you might be able to see that star, that metal-free star. You
Yeah,
might-
yeah.
Yeah.
Most of those stars, I mean, any star that's on this chart is definitely visible.
Yeah, it's oh shoot, I don't know what the I've got it written down somewhere, but I certainly will want to look at see if I can see that, just to say that I've seen a star that old.
That's, yeah, okay.
All right, let me stop sharing.
Yeah,
Hey, May's back.
May's back.
I got a question for you. On the slide with the black hole, there was something labeled ESO and HLX. I hadn't seen those acronyms. What are ESO and HLX?
I think ESO is European Southern Observatory. And
I don't know what HLX stands for.
I don't know what HLX is either.
Thanks.
Anybody want to do a quick search online to see what it is?
Hyperluminous X-ray source.
Ah, there you go.
Cool.
All right.
All right, Vanessa.
Hyperluminous X-ray.
All right, so my turn now. Let me get my share screen up here. Okay, everybody see that all right?
No.
Yep.
Yep.
Got it?
Okay, yeah.
Okay, well, let me. Well, it's not- I have. Okay. Sorry about that. I can't switch it to slideshow. Give me a second. Now I have. Okay. Okay, so tonight I'm going to finish off. We've been doing a whole series of talks on all the different planets in the last few months. And this is the talk on Mercury. So, and I always start off with a little comedy. So there's the astronauts looking at the obelisk on the moon from 2010 or 2001, and it's got an Apple logo on it. All right. Okay, so a little bit of background, of course. Mercury is the smallest planet in our solar system, since Pluto is no longer counted as a planet. Mercury is the closest planet to the sun. Mercury is probably the most difficult planet to observe because it never gets very far away from the sun. It only gets 28 degrees from the sun at greatest elongation. It's one of the original naked eye planets that's been observed all the way back to prehistory, if you like. The earliest known observation that was recorded was by some Assyrian astronomers, probably in the 14th century BC. And Mercury, just like Uranus and Neptune, has not been explored much by spacecraft. There's only been 2 spacecraft that have gone to Mercury. One of them was a flyby and one of them was an orbital spacecraft. That's all that's ever been there. So Mercury is named after the Roman messenger god with the wings on his feet, which the Romans called Mercury, the Greeks called Hermes. The astronomical symbol for Mercury is kind of like I don't know how you pronounce that word, caduceus. It's the symbol for medicine, but it's got the
Yes.
wings and the snake and so forth. And so the symbol for Mercury is the one on the left there. And it's sort of, you can see the wings and the etc. Yeah, the first written record of Mercury was in what's called the Mal-Apin tablets, which are observations, like I said, made by a Syrian astronomer in the 14th century BC. Our friend Ptolemy wrote about the possibility of planetary transits across the face of the sun, but he also suggested that no transits had ever been observed because the planets, like Mercury, must either be too small to see or because the transits were too infrequent. That's, in the case of Mercury, it's too small. You can't see a Mercury transit with your naked eye. You can see a Venus transit with your naked eye, but in the case of Venus, it's because they're too infrequent. The first telescope observation of Mercury was Galileo, but he could not see the actual phases. He had a really small telescope, and so he didn't see the actual phases that it went through. In 1631, Gassendi actually observed a transit of Mercury across the sun that had been predicted by Kepler. And in 1639, Giovanni Zuppi used a telescope to finally see that Mercury went through phases, just like Venus and the moon. And that observation demonstrated for sure that Mercury orbits around the sun. And there, Galileo, Gassendi, and Zuppi there on the bottom. This is something I didn't know until I did my research. There is actually, Venus will occult Mercury. Not very often. Every, what did I say here? It's like every few centuries, every 300 years or something. It looks like almost 400 years. Venus actually occults the planet Mercury, which that would be a unique astronomical event. The only one that's ever been recorded was the one that occurred on May 28, 1737, by an astronomer named John Bevis at Greenwich. The next occultation of Mercury by Venus won't be until 2133. Sorry, folks. We don't get to see it. This animation down at the bottom is what Bevis would have seen as the planet Venus moves across and covers up Mercury. Venus is the big thing, Mercury is the smaller one. throughout most of the history of telescopes, up until very recently, it was all, Mercury is an incredibly difficult object to look at. The best telescope observations were still not very good. Down below there, that bottom right image is considered one of the best telescope images ever taken of Mercury, believe it or not. The problem you have is that it's very close to the sun, so that makes it difficult. And because it's close to the sun, it never gets very far when you're looking at it right after sunset or right before sunrise. You're looking at it very close to the horizon. So you're looking through a lot of air. You're looking through the thickest part of the atmosphere. You're looking, there's all kinds of currents in the air when close to the horizon. So it's really, really hard to get a good view of Mercury. And so seeing any kind of surface detail, like basically impossible. Right up until the advent of, so they started mapping it with radar, okay, where they were finally able to map the surface using radar. We weren't even sure how long the day was on Mercury. We knew the length of the year because you could, measure how long it took to go around the sun, but we had no idea how long the day was. And most astronomers believed that Mercury was in a tidal lock with the sun. The length of the day was the same as the length of the year, so that the same face always faced the sun for the entire year. Interesting note, which is no surprise, the Hubble Space Telescope has never looked at Mercury. It can't. There are limitations. They can only go so close to the sun. They don't want to take a chance on burning out the equipment. So they won't ever look that close to the sun. So they will never look at Mercury with Hubble. Finally, 1965, that's what I mean, very recently, finally, up until that, Mercury's year and day were thought to be the same length of time. Finally, in 1965, a couple of astronomers started observing Mercury using radar, using the 300-meter dish at Arecibo. And on their observations, they were able to figure out that the year is not the same as Mercury's day. Turns out Mercury's day, the time it takes to revolve 360 degrees on its axis, is basically 2/3 the length of its year. Its year is 88 days. Its day is 59 Earth days. It is locked in a resonance with the sun, but it's not quite a 1-to-1 resonance. It's a 3-to-2 resonance, which also explained why whenever astronomers looked at Mercury to try to see surface details, they were always seeing the same thing. Because if you look at the 3-to-2 resonance and you look at how the Earth moves around the sun and so forth, every time Mercury is in a good position to observe from Earth, you're basically looking at the same side of Mercury every time. And so they were always seeing the same thing over and over again. So they just figured it must be locked in tidal resonance. So as I said before, only 2 spacecraft have been to Mercury. Mariner 10 did several flybys between 1974 and 1975. And the Messenger spacecraft actually orbited Mercury from 2011 through 2015. There is another mission being planned. It's already been launched, actually. A joint mission between the European Space Agency and the Japanese Space Agency was launched in 2018 and will arrive at Mercury in 2025. So Mariner 10, that's the spacecraft up there in the corner on the right. It made 3 flybys of Mercury. It had pretty good instruments and provided a lot of information. It confirmed the 3-2 resonance. But because of the flybys, it only did flybys, and each time it did a flyby, the same part of Mercury was being lit by the sun. So it saw the same thing. As a result, it only mapped around, and how did I cut that off? I cut off that line. As a result, it only mapped about 45% of the surface. So there was still a lot that we hadn't seen. These are a couple of images from Mariner 10. The Messenger spacecraft entered orbit around Mercury on March 18th, 2011, and it remained in orbit until April 30th of 2015. So it was there for 4 years. It took 7 years to get there. It had to do 3 flybys of Mercury, 2 flybys of Venus, and a flyby of Earth to finally get into a Mercury orbit. All of those flybys were necessary because to minimize the amount of fuel that it used. It wanted to use gravity assist to alter its velocity to finally get it into the right place at the right time. Just a note, if you remember my talk on Venus that I did some months ago, I told you that it actually is very difficult, more difficult to go from a higher orbit to a lower orbit, like Earth to Venus or Earth to Mercury, than it is to go the other way, going out from like Earth to Mars. And that's one of the reasons, frankly, why the US space program did a lot of work on Mars and did not do much work on the inner planets until very recently, because it's considerably more difficult to do. But anyway, so Messenger got in there in 2011 and stayed there for a while, had a lot of instruments. They were all powered by solar power. Being that close to the sun, had lots of solar power. The instruments included 3 different devices for imaging, 5 different spectrometers, a magnetometer, an altimeter, and a radio science experiment. And that's an image of, that's a artist's conception of the Messenger spacecraft in orbit around Mercury. So Mercury, like I said, it's pretty small. It's 0.055 Earth mass, so it's really small. Its radius is about a little over 2,400 kilometers. Its orbital period is basically 88 days. The length of its day, the time it takes to do one 360-degree rotation, is a little over about 58.5 days. Its average distance from the sun is a little over 1/3 of the distance the Earth is from the sun. Maximum temperature on the sunlit side is 427 degrees centigrade. Minimum temperature at the poles in the shadows, it gets as cold as 193 degrees below 0 centigrade. It's got a highly eccentric orbit, 0.2. It's inclined about 7 degrees with respect to the ecliptic, so it's just a little bit out of the plane. Its density is very high, 5.4 grams per cubic centimeter. Earth is 5.5, so it's almost the same as Earth in terms of its density. Its axial tilt is basically 0. So its poles are basically lined up with at 90-degree angles with respect to the orbit. The surface gravity, if you were standing on the surface, it's just a little over 1/3 of Earth's surface gravity. One of the things that Mercury is important for in terms of modern physics is what's called perihelion precession. In Newtonian physics, any 2-body system consisting of one really big object like the sun and a smaller object like a planet orbiting would trace out an ellipse. This is one of Kepler's laws, right? The planets orbit in ellipses with the sun at one of the focus points of the ellipse. The point of closest approach is called perihelion. And in the ideal system, if there were no outside forces acting on that system, that point in space where the perihelion is located would remain fixed all the time in space, same place, okay? Now, in the solar system, you have a number of things going on. You have other planets going around the sun, and they all exert gravitational forces on Mercury. And then you have the fact that the sun is not a perfect sphere. It's oblate, it's flattened because of its rotation. So the mass is not distributed in a spherical way. As a result of that, the point of perihelion precesses around during its orbit. It's like this, that typical spirograph picture. Each orbit, the point of perihelion moves a little bit. That's greatly exaggerated, but that's what it does. It moves around over time. So the orbit traces out this wonderful spirograph figure. Now, so all of those effects that I just talked about can be computed using standard Newtonian physics. And they did that, and they did that for all the planets. And what they found was that Mercury, the amount that its perihelion precesses is deviating way outside of what you would consider the error margins of your calculations by a fairly large amount. And they did not have an explanation for this. And this anomaly, if you want to call it that, of the precession was first brought up as a real problem in celestial mechanics by a guy named Urbain Le Verrier in 1859. And he computed that the difference, the precession was off by like 38 arc seconds per century. That's way outside the error margin. The error margin of the calculations was just like 5 arc seconds per century. So it was way outside the error margin. Later, the estimate was refined a little bit by a guy named Simon Newcomb in 1882 to be 43 arc seconds per century. So that was completely unexplained. No one could explain that. A number of explanations were tried, and they all failed. Then comes along our friend Albert Einstein. And when he put in all the information about Mercury into the equations of general relativity, out popped the answer. The general relativity effects, if you look at this table here, so there's the precession of the perihelion for Mercury. The total precession per century is 574 arc seconds per century. So 532 of that is coming out of the perturbations by the other planets in the solar system. There's a small 0.02 is caused by the sun not being a perfect sphere. And then the difference, 42.97 comes out of general relativity, and this other one is minus 0.002. That's actually also a relativistic effect. And that makes up the difference so that now you get the correct number. And so this was a really powerful proof that Einstein was right with general relativity. And this is used as one of the arguments in favor of Einstein's general relativity, that it correctly predicts this precession. And now all the planets have this general relativistic effect in their precession, but to a much smaller effect, because the precession is dependent on how far the planet away is from the sun, how elliptical the orbit is, and so on. And Mercury is your worst case in that sense. So in terms of what Mercury is made out of, turns out Mercury seems to be structured very similar to the way the Earth is structured. It has a solid silicate crust and mantle on top of a an iron or iron sulfide core, and there's a deeper liquid core, and then a solid inner core. And the cores are probably all iron. The planet's density, like I said before, is the second highest in the solar system. In fact, if you took away the gravitational compression, because in the Earth, the core is compressed by gravity because of all the rock on top of it. If you took away that compression factor, Mercury would be denser than Earth in terms of the materials. So in order for it to have such a large high density core, it's got to be very rich in iron. Geologists estimate that Mercury core occupies about 55% of its volume, which is a huge amount. Earth's core, on the other hand, only represents 17% of its total volume. So Mercury's core is really big. And current research suggests that the core is molten. It has a molten iron core. And then surrounding that, it's got a mantle with silicates and so on. The crust is estimated to be anywhere from 35 to 26 kilometers, depending on which research you read. One of the interesting features you find on the surface is that there's these large scarps, cliffs, that they think were formed as Mercury cools, it's contracting. I think like this picture on the right here, bottom right, you see that large cliff feature running through the middle of the picture? You notice how it runs right through the middle of the craters, which indicates it's younger than the craters. It must have happened after the crater was formed. So there's a lot of these things on the surface that strongly suggest that the planet is shrinking as it cools. Yeah, so here's a cutaway diagram showing kind of the structure. There's a crust and a mantle, a molten core, and then a solid inner core. Mercury's surface, no surprise here, looks a lot like the moon. It's heavily cratered. It has plains. It has all the same kind of geological features that the moon has. It has mountains. It has plateaus. It has maria and other things. It has impact craters with ray systems. The one, like I said, the one strange feature that it has that you don't see much on the moon are those ridges, those cliffs. The naming for the features on Mercury is interesting. They're named after, most of them are named after people. Artists, musicians, painters, authors, etc. Scientists who have contributed to the study of Mercury. Depressions are named after works of architecture, which that's interesting. Plains are named after the word Mercury in various languages. And escarpments, those cliffs, are named after ships of scientific expeditions. And the valleys are named for abandoned cities and towns. Interesting naming convention. This is a topographical map of Mercury from the MESSENGER data. The red areas are highlands, areas that are above the average height. The green, the dark green areas are deep depressions that are really dug down deep. And then the yellow is like the average. So you can get an idea of what the surface looks like. Chemically speaking, the surface geology, it's gone through a lot of the same interesting phases that the moon probably went through. It's got minerals that were overturned by convection. There's large variations in the composition on the surface. The crust does not have much iron, which is not a surprise. Most of the iron will have settled down into the core. But the crust, as it turns out, is high in sulfur, which I think is due to weathering, space weathering. The surface is dominated by pyroxene and olivine. These are two interesting minerals that they actually looked for on Mars. There's some sodium, I can't pronounce that, plagioclase, and other minerals of magnesium, calcium, and so forth. The darker regions that are less reflective tend to be high in carbon, mostly in the form of graphite. These four images here are mosaics from messenger data, which are the different colors represent different compounds, structure, different compounds, chemical compounds on the surface. I already talked about this. So it's got this compression fault, they're called compression folds. You see these all over Mercury. Some of them are quite large, as long as 1,000 kilometers and as much as 3 kilometers high. And like I said, they're on top of other features which indicate some of them are very recent. They suggest that Mercury has shrunk in radius by anywhere from 1 to 7 kilometers since the surface was formed initially. Most of these larger features, they think, probably occurred about 3.5 billion years ago. But they are seeing small scarps, much smaller in size, 10 meters in height and maybe a few kilometers long. Some of these appear to be less than 50 million years old based on their estimates of the age. And that indicates that there's some activity perhaps still going on today. One of the other surprises from Mare 10 and Messenger was that Mercury has a pretty strong magnetic field. They did not expect this because Mercury takes such a long time to rotate on its axis. They didn't expect it to have any magnetic field. As it turns out, it has a very strong magnetic field, strong enough to deflect the solar wind, strong enough to have a north and a south pole, dipolar. It's about 1% the strength of Earth's field, but that's actually pretty strong compared to some other planets. And what they think is happening is that it is being generated by the spinning of the iron core, but they think most of that dynamo effect is being caused by tidal effects by the sun. Because the orbit is very eccentric, the core is getting tugged, pushed, and pulled as it goes closer to the sun and farther away from the sun. And the tidal heating is what's keeping that part of the core liquid and keeping it circulating. And that's what's causing the magnetic field. This graph shows the strength of the magnetic field as you go across from front to back, if you like. And the other surprise, which was confirmed by the spacecraft, there's water on Mercury in the form of ice. The radar observations at Arecibo indicated that there are craters near the North Pole and the South Pole that are in perpetual darkness. They never get any direct sunlight. They're in shadow. The deep inside of the craters is in shadow all the time. The radar reflectivity off of that areas indicated that there might be some kind of ice there within those craters. They're very bright in radar. When Messenger got there, they were able to use their spectrometer data and everything else to determine that there is indeed ice. And in fact, it's water ice. And the picture on the left is showing temperature over those areas, and the dark purple areas are the areas that are very cold. And in this image on the right, which is basically the same area from a slightly different perspective, the yellow areas are the areas where they detected water ice in the craters. And that's it. I'll take questions now. Any? Okay. No questions?
Wait a minute.
I put a question in the chat.
Go. I didn't look at the chat. Oh, let me look at what's in the chat. You could interrupt me when I'm talking. You don't have to wait for the chat.
It was about the Parker Solar Probe because you said,
Parker Solar Probe is not going to Mercury.
yeah, and I know it did some Venus. It did some stuff on Venus to
Well, it may be doing flybys
flies.
to correct its
For gravity,
velocity,
it
but
says.
it's not designed to do that, to go to Mercury. I don't think it's going to Mercury at all. I think it's just doing flybys of Venus.
Yeah, just for the
Yeah,
get into orbit.
Gravity assist and the data dump back.
yeah. Oh, and Dan must have made the comment, oh, darn, I'm not going to see the next one. That's
Yeah.
the occultation of Mercury by Venus. Yeah, we're not going to see that.
Yeah, we won't see any more Venus transits either. I mean, Mercury
No,
transits.
we won't see any more Venus transits in our lifetime either, unfortunately.
And Mercury, yeah, we had a Mercury transit last year.
Yeah, there's one about every 7 years.
Yeah. Oh, okay.
So you'll get a chance to see another one.
Oh, okay.
Hey, Doug, you said the magnetosphere traps plasma, or did you mean deflects it?
Does both, actually. There's actually a considerable bow shock. And if Mercury had an atmosphere, it would have very spectacular aurora.
That's what I was wondering, yeah.
Yeah. That was, like I said, that was one of the big surprises, because they figured the planet is taking 59 days to rotate on its axis. They figured it's a long dead planet by now. It shouldn't have a magnetic field. Yeah.
Interesting that they're not believing, or that they think the planet shrunk, because when you have, at least to my knowledge, a liquid core, some volcanism, and a magnetic field causing that core to rise and lower, that you don't have plate tectonics.
Right, but they think what happened, they don't think the core has shrunk. They think that the mantle and the crust, they think that the crust probably formed very early on as the planet started to cool down. And then that mantle area has contracted as it's cooled down. And as a result, the crust had to go crunch like that.
Yeah.
And so it shrunk. And there's no plate tectonics because you don't have a liquid lava mantle with currents driving any plates. The mantle is, they think, kind of not even in a liquid state.
Okay, that's interesting.
So yeah, I'll be real interested when the next spacecraft gets there in a few years. Mercury would be, if you think about, if you want to, they talk about mining minerals and things from the asteroids. Mercury would be a prime target to do space mining to get, because it's very rich in all of your heavy things like iron and all kinds of metals and stuff. It's just a lot. It's like I said, it's probably richer than the Earth is in terms of those type of minerals.
So something that's a rare earth metal could be a predominant Mercury metal.
Could be.
Yeah. Go there to make cell phones. Because that would be an expensive prospect to do any mining.
Well,
on.
I mean, you talk about they talk about commercial mining on the asteroids. How much more expensive can it be to go to Mercury?
There was a science fiction.
Getting out of Earth's gravity well is the most expensive part of any of those projects.
There was a science fiction book, and I can't remember what the name of it was, but it may have been called the one of the Blue Mars series or Green Mars series books. But their premise was that Mercury had been colonized, and the city they built on Mercury was on a railroad track, and it stayed just ahead of the Terminator.
Oh, okay.
So, that's got to be
right where the temperature was not too hot, not too cold.
the Goldilocks zone.
Yeah. Okay, that's a new one. I hadn't heard of that one.
I think it's the
Here for Earth now too.
yeah. I think it was the Red Mars, Blue Mars, Green Mars trilogy.
Okay.
Not positive about that though.
Are there any other questions about anything we discussed tonight? Okay, then that'll do it for tonight's meeting, everybody. Hope to see you again in July.
Or just want to let everybody know that TIMP is open tomorrow and Saturday.
I'll be there Saturday.
Yeah, we'll
Okay.
see you Saturday. Is
Good.
Ralph going to be out there?
No, Ralph is working Saturday.
Okay. He'll be there tomorrow.
Oh,
Okay.
Yeah. Okay, well, see you guys there.
All right. So May, how do I do this stop recording? I just push the stop button?
Yeah, and in fact, if you go out of Zoom, it'll stop recording too.
Okay. And where does it put this? Where is it going to put the recording?
It'll send a message to the host asking about the recording. It usually takes like overnight for you to get a message back.
Okay.
But then it'll send a message, asking if you want it in the cloud or, what you want to do.
Okay. All right. I'm going to push the button.
Okay. Sounds
All right.
good.
Do you want to stop clouding recording? Yeah. Good night, Kay. All right. I'm going to say yes.